Okay, so slope of triangles worksheet. This is pretty much the same stuff we've been doing. We're still using the slope formula where it's y2 minus y1 over x2 minus x1. On the first part, we're just going to worry about slope. We're not finding the y-intercept. And the thing you need to know is that when you have two triangles and their longest sides lay on the same slope line. So in this case, there's my slope line, and there are the two long sides of the triangle, or basically the same side. Okay, this is the same side of the triangle as this on the other one. Like those are proportional sides. If they're laying on the same line, they're going to have the same slope. And so to prove that, we're going to use the points that they gave us, and we can solve the first one first. And honestly, when you get going, just solve the smaller triangle. Just solve one of them. They're going to be the same. So I'm going to go ahead and label these first 2 points, x1, y1, xy2, and I'm going to use that formula, the same slope formula we've been using. So my y2 minus y1 over x2 minus x1. So y2 is 8. So 8 minus y1, which is 4, over x2, which is 20, and x1, which is 10. So 8 minus 4 is 4. 20 minus 10 is 10. And if I reduce that down, say I divide them both by 2, I get 2 over 5. Okay, so just to check the idea that they're the same slope, I'm going to use these 2 points to find the smaller triangle slope. Since that's already labeled x1, y1, I'll keep that the same, and I'll just label this one x2, y2, and I'm going to use the same formula. So y2 is 2 minus y1, which is 4, on top of x2, which is 5, minus x1, which is 10. And I get negative 2 over negative 5, which when you have two negatives, those cancel out. So I really have positive 2 over positive 5, okay? So that means they're the same, and that would be how you put your answer in on Schoology. It's going to be in fractions today. So like on number 2, I would just find the points, and remember, you can only use the points that are on this line. So that means this point is off limits and this point is off limits. You may not use those. That's not going to help you. So, but I'm going to use the points for this smaller triangle. So this point is at negative 1, positive 1. And this point here is at negative 4, negative 1. Okay, and I'm going to label these. So I've got x and y. I'm going to label this one my 1s. The bottom one can be my 2s, and I'm going to use that formula. So y2 minus y1 over x2 minus x1, which was negative 1, so I had to do minus negative. So negative 1 minus 1 is negative 2. And then negative 4 minus negative 1 is negative 3. So those two cancel out. So positive 2/3 is our slope on this one. And like I said, you can do this one if you want to. You can do the bigger triangle. But a quick way to do it is just to do the small triangle slope. And then you won't have to reduce. You'll just get your answer. On number 3, like I said, let's use the smaller triangle. So there's 2 points here. A is at negative 3 and 6. And C is at negative 1 and 3. Okay, so when I label them, this is xy, 1, 2, and we're going to use the formula again. y2 minus y1, x2 minus x1. So that would be 3 minus 6, negative 1 minus negative 3. So solve that, and that will be your slope. On number 4, again, I would use, remember what's off limits? These are off limits, but you can use J and L because those would be the smaller ones. That would be easiest. So J is at -7 and 4. And L is at -4, 0. So we label it X, Y, X, Y. This can be my 1s, my 2s, and same formula. Y2 minus Y1 over X2 minus X1. Same thing. I would solve using C and E. So C is at 9 and 6. And E is at 12 and 8. Label them however you want and use your formula. Y2 minus Y1, X2 minus X1. Yep, same thing on this one. You can use B and you can use C. That would be the best ones to use. So B is at 3, 3, and C is at 9 and 7. So however you want, X, Y, X, Y, that can be 1s, that can be 2s. Plug them into your formula, and that will give you your slope. On number 7, they gave you points, so I would use the 2 smaller ones so then you don't have to reduce, and label them however you want. If you want to do X1, Y1, X2, Y2, that is totally fine. Use your formula. And I'll get you your slope. I think it was this one. So this one's kind of weird because it's not very clear on the smaller triangle where it's at. So I would probably just use A and B. They're the bigger ones, but I think it'll be a little bit easier. So A is at 4, 4, and B is at 8 and 7. Okay, so when we label these, they're X and Y. These can be the 1s because I wrote them down first. And then plug into that formula. So Y2 minus Y1 over X2 minus X1. So 7 minus 4 is 3. 8 minus 4 is 4. On this one, calculate the slope and the Y-intercept. I always look for the Y-intercept first because it's easier. And then I can use that as a point to find my slope. So there's your Y-intercept, +1. And then I'm going to use that point. So that point's at 0, 1. And I'm going to use this point also. So -2, 4. Okay, same thing, X and Y, 1s and 2s. And use your formula to find your slope. Number 10, same thing. Your Y-intercept is the easiest one. It's at 4. And then label however you want. You can say this is X and Y 1s, X and Y, and those are my 2s. So plug into your formula over here. For the tables, same thing. We're going to label, I'm going to pick these 2 because they're small and they're positive. So this is X and Y, this is X and Y. I'm going to label these my 1s, my 2s. So we're going to do 36 minus 24 over 5 minus 1. So 36 minus 24 is 12. 5 minus 1 is 4. So when I divide that, we get 3. And now I have to use that slope to find my Y-intercept. So I'm going to start here because I have to work back to 0 on the x-axis. So if I have 1 and 24, X and Y, and I have to get back to 0 because that'll be my Y-intercept, whatever I get over here, then that means I'm just going to subtract the slope one time. So when I subtract my slope of 3 one time from 24, I get 21. And down here, they already gave you the y-intercept. So all you have to do, use whichever 2 points you want. Say you use this one and find your slope. Okay. This one was kind of weird. So I'm just gonna pick these top two. I'm gonna label x1, y1, x2, and y2. So I'm gonna do my formula, which would be y2 minus y1. So it has to be minus -4, because that's what my y1 is. So x2, -5, minus -6. Okay, it's kind of weird. So -9 minus -4 gives me -5. Then -5 minus -6 is 1. So my slope is -5. Now here's where it gets kind of weird. So usually we're working our way up on the tables, but this time, I clicked on something weird, hold on. This time we're gonna have to work our way down because I'm trying to get to 0 on the x side. So if I go down one time, that's -1, and then 0. Okay, so I put too many arrows, that's my bad. When we go up, like when we have to go backwards, we are subtracting. So that means if I'm going this way down the table, I'm adding. So we're gonna say -24 plus -5, which seems weird, but that's the easiest way to do it. So when I do that one time, I get -29. Okay, and then I need to do that one more time, plus -5. And that gives me -34. So now I'm across from the x on the x axis, not axis, but part of the table. And so my y-intercept is -30. Same thing on these. Use these to find your slope. x1, y1, x2, y2. There's a hint there because you're going to get a decimal as your slope, and that's okay. And what's going to happen is you're going to go backwards in your table. So you've got 1 and 2 on your table already. So you would just have to subtract 1 and subtract your slope one time to get your answer here for your y-intercept. 15 is a little bit weird too. I would use, let's just use these for our x1, y1, x2, y2. y2 minus y1, x2 minus x1. So I've got -5 minus 0 and 6 minus 1. So -5 minus 0 is -5. 6 minus 1 is 5. And that, when we divide that, we get -1. So now I need the y-intercept. A lot of people have seen this today and said that 0 was their answer, and that's not true. We need 0 to be over here. So I am gonna kind of recreate the table. So I have 1 and 0. So to get to 0 here, I'm just going back one time. So that means I'm gonna subtract my slope one time over here. So just 0 minus 1, which is -1. So there's your y, there's your slope. Solving equations, if you still need help with these, I can help you. But the easiest thing to do is box them all in with the signs in front and move one of your numbers first, the plain numbers. So I would add 61. So then -50 plus 61 is +11. And then we're going to bring down, sorry, that's positive, bring down everything that's left. So 2x, the equal sign, and then 3x. And then I'm going to do the same thing. I'm going to box everything in with the sign that comes right before it and subtract what I can. I can't move the 3x, but I can combine with it. So the only thing that'll combine with an x is this 2x. The 11 is just a plain number. I can't move him. So minus 2x minus 2x. 3 minus 2 is 1. So x equals 11. And the same thing on these. Make sure you're boxing in the signs. And last part, true or false. Triangles on the same line can have different slopes. Go back to the first page if that is confusing. 20, the slope formula is